Well, hello everyone. Welcome back to the bench. And as you can see, the bench is completely full. I have the wide angle lens on the camera. And yep, we have a Pioneer SX-1250. And I tell you what, if they sold these by the pound instead of, if that's how they priced them, was by the weight and not by volume, well, even by volume. Doesn't matter if you price it by weight or by volume on these ones. This would be an expensive receiver. The owner sent this in, and yes, the knobs were removed for shipping. They're all safely packed in bags. He did a really fantastic job of packing it. It got here safely. And what he wants to do is he wants us to go over the entire receiver, top to bottom, fully test it, repair anything that needs repaired, although this is supposed to be in good functioning order, and it is supposed to be all original and unserviced, untouched. And once we do that, he even sent, let me see if I can show you here, this big giant box full of all the parts necessary to completely restore this thing. Every capacitor, every component, even all of the great big 22,000 microfarad capacitors. 4 of them. Oh yeah, 4 of these big things. Everything to do the restoration. So he really wants this thing done up right, and that's great. And just give you guys a little heads up. I hear a rumor that this one might possibly go up for sale after we're done with it, but not sure yet. But I'll tell you what, this is a fantastic receiver. Any of you that have followed any of this type of equipment, at the time this came out, this was Pioneer's top of the line receiver. It's one step above the SX-1050, which you've seen me do a couple of those on here. It's very similar in design to S1050 with increased power. So instead of 120 watts per channel, I believe this one's 165 watts per channel. And when they went to the 1280, they upped that to, I believe, 185 watts per channel. So way more power than most of us are going to ever need. But beyond that, the circuit design, the performance of these are really, really good. These are some of my favorite line of receivers, as you probably already know. And this is going to be a pretty fun thing. So if this sounds good to you, grab your hernia truss and put it on, and let's get ready to lift this thing up and flip it over and get it apart and take a look at it and do some tests. Okay, we're going to turn this thing on, and with this type of thing, unless you have a really big dim bulb, I'm going to show you that a dim bulb tester doesn't do you much good with one of these receivers. So over here is the dim bulb. You can see it. Let's turn this thing on and watch what happens. Put on your sunglasses, and you can see how long it's taking. And there, the protect circuit just kicked, and now it kicked back out again. So you can see the idle current of this receiver is so high that the dim bulb tester will actually cause the protect relay to kick out. And that bulb will never go dim just because there's so much idle current. Now let me show you how much idle current this thing has. Okay, I have the kilowatt connected, and this is plugged into the isolation transformer, this strip down here. And it's a big isolation transformer. This is I believe this is a 1 kilowatt isolation transformer sitting on the floor next to the bench. So it's a heavy duty one, but it still actually will sag when you crank the power up on this amp. But just to show you what the idle draw on this receiver is, we turn it on. You hear the protect relay kick. And you can't really see this, but right here, right now, this receiver is drawing over 65, almost 67 watts of idle current. And once the transistors heat up, it'll actually settle at about 70 watts just at idle. And really I don't think there's any DC right now on the terminals at all. I have it connected to an oscilloscope, and there doesn't seem to be any offset, so there's no problem like that. It's just this thing draws that much current. Now, we may be able to reduce that a little bit. I don't know if the main filter caps are leaky, and I don't know what these really are supposed to draw when they're running at full, when it's running normally, what the draw is, but 70 watts. So let me get it plugged into a solid outlet that goes directly to my breaker panel, and we'll see what this thing can do. Okay, from this point on, you folks should know the routine by now. I have my, let's see here, that's better. So I have my oscilloscope connected. I also have my dummy load connected, and I have an 8 ohm non-inductive load on there. And this dummy load on the bench is actually good for 300 watts per channel at 8 ohms, so it's more than adequate to handle whatever this thing can put out. I have a 1 kilohertz tone going into the auxiliary jacks. I have the tone in defeat, so there's no tone controls connected. And I'm driving about 1.7 volts RMS into the auxiliary jacks so that we can be sure to drive this into clipping. So here we go. And if you look at the bottom of the screen, this is going to give you the RMS voltage. Right there, we're starting to clip. And we're right at about 39 volts. Bring it down a little bit. Let's say 38 volts. Okay? So let's do our math. Right? And that gives me 180.5 watts per channel. So this is a 160 watt amp, and as you can see, it's doing 180 per channel very easily. And this is with all 1970, what is this, 1978, 1977, something like that, hardware in it. That's pretty impressive, I think. Pretty impressive indeed, right out of the box. So I think when we get this thing all done up, it's going to really be a really amazing performer. And I'm really excited to see how the tuner works, because I hear that the tuner in this is actually one step higher than the tuners that are in the SX-1250s. So this is going to be close to that TX, not quite to the TX 9800, but to my TX 9100. I'm assuming it's going to be very, very similar to that tuner. So let's get this thing apart and take a look at the insides. Okay, we're in, and as you can see, this tuner is nice. It's all shielded and everything. But the most impressive thing is when we get back here to the power supply. This is the business end of this receiver. And if you notice, here's my hand, and here's the transformer. And this is a toroid transformer, and it actually has two separate sets of windings for the right and left channel. It's a split power supply for the output section of the amplifier, but it uses a shared power supply for all the low voltage things. So if you take a look at the schematic here, I turn this off, you can see that, let me see here, you can see right up in this section, this is the first rectifier, and this is the first coil here. And there's your plus and minus 70 volts, and there's your 22,000 microfarad capacitors, two of them. And this goes over to the one channel. And then down here along the bottom, you see another rectifier, bridge rectifier, and you see the other 22,000 microfarad capacitors feeding this channel. And you can see that in here, where this board has the protect circuit on it, and the rectifier for this side, plus your capacitors. Then this side is the low voltage power supply board and the bridge rectifier for these capacitors. So Technically it's a split power supply, but only for the output section. Toroid transformers are very efficient at delivering very high currents, especially like surge current. That's why they're favored in this type of application. So you can see we're running a plus and minus 70 volt rail, and because of these great big capacitors, the inrush current on this receiver is, you know, upwards above 200 amps if you did not have any kind of a soft start circuit in there. So again, this is going to have a soft start circuit to limit the inrush current until the capacitors get all charged up and or at least partially charged. So we can see this is a little bit similar to the SX-1250. If you look, there's a big 20 watt resistor that's very low resistance. I don't know if I think that should say something like 3.3 ohms or something like that, or 33 ohms. And there's also a fuse that's in line with this. It's kind of a, I believe it's a thermal fuse. And if you notice this set of contacts here for your soft start circuit, it starts out with this relay dropped out. And what it's going to do is the power coming from the wall is going to be directed up through this resistor and into the transformer, and that's going to limit the inrush current to the transformer. Once the capacitors gets charged up to a certain level, this relay will pull in and bypass this resistor and allow the full current to get to the transformer. Otherwise, this transformer would draw so much current from the wall that it would blow this big fuse here, which I believe is a 12 amp fuse. It would blow that fuse, and it would probably take out the breaker in the wall because of the inrush current. So we call that a soft start circuit. It's pretty common in industrial electronics. You don't typically see such things in commercial electronics at home unless you get into these great big receivers. And if you look at the video that we did on the Sound Craftsman, you'll notice that in the Sound Craftsman video, I showed you a different type of soft start that used SCRs to basically achieve the same thing in kind of a different way. So, all right, let's take a look a little bit more in here and see where we should start. Okay, you can see we're in here now, and there were some screws missing, and it's possible that this receiver was serviced at one time. But so far, I don't see any signs of much of anything that was done to it, if anything. Maybe an alignment or something, I don't know. But much easier than the SX-950. Here's the bottom of the tuner board. Everything is really, really accessible, very neatly put together. These come out as modules and are very easy to service. Yeah, there's definitely been service, though. If you look up here and you zoom in, we see clues. You can see where this was clipped off and soldered back on for whatever reason. So yeah, some of these may have been taken out, and they may have been taken out just to be cleaned, just to clean the pots. This one also here was removed. You can see a few of these, and these are the short wires that need to be removed in order to get it out. Instead of doing the wire wrap thing, somebody just clipped them and soldered them back on. That's pretty common to see. So I'm assuming that right now, from what I see, the only service that's been done on this receiver has been just basic, maybe an alignment, you know, or at least a tuning, you know, alignment of the amplifier and cleaning the pots and switches, and not much anything else. Looking at these capacitors, I'm kind of glad that the owner did go ahead and order replacement capacitors, the main filters, because you can see inside here, and don't worry, these are discharged. Just some of these are getting puffy here. They all four look a little bit different than one another, and I have a feeling they're a little bit starting to get a little bit leaky. and the ESR is starting to climb on them, and that's a good possibility as to why the thing draws so much idle current right now. I kind of think 70 watts is a little bit high, even for a big amp like this with all these transistors. I just still think that's a little bit high. As you can see, everything's connected with plugs, easy to take apart. There is your soft start resistor right there, and your little thermal fuse. I always find it funny that they tape it together with masking tape. That's factory. That's how they do it. But this is the big ceramic resistor that, and it is 3.3 ohms. I actually have a spare one here I was looking at, and it is 3.3 ohms at 20 watts or 50 watts or something like that. So, and then somewhere, I can't remember where the relay is. I think it's either this one. This is either the protect relay. I can't remember. There's two relays. There's one here and there's one on the board. And one of them is the protect relay and the other one is the actual inrush current relay. I think this is the inrush current relay, but I'm not positive. So anyways, yeah. This looks like it's going to be pretty good. There's a lot of capacitors, and the owner was very specific. He wanted it all recapped, everything replaced. I think he even sent a lot of the transistors, although I'm not a big fan of replacing transistors unless they really need it, because as you can see from my other videos, finding matched pairs that are properly matched and everything, it can be a chore. And even though you can put unmatched transistors in and they will work, when you're working at really low volumes, you can notice the distortion and so forth sometimes. So I kind of like to have matched transistors. But anyways, but if one of them's bad, I like to replace the whole set then, so that we know we have the same types in there. So it's good that we have them. Anyways, there you go. I'm going to get to work on this thing and start recapping it and get that part done. I'm going to test out the tuner and the rest of the controls before I start any work, so I can document if there's any problems ahead of time, and then we'll go from there. Alright, we'll see you shortly. Alright, we got the power supply underneath the chassis done, and we got the big capacitors replaced, and I just started on the low voltage power supply. And first thing I noticed when I got it out here was that this screw on this side was missing altogether. This one was in. And then I kind of started looking closer, and things weren't looking original. And when I took it out, you can see lots and lots of work has been done on this thing. I don't know if you could see that, but all this in here has been replaced. All this down here has been replaced. Either somebody was just kind of shotgunning this and replacing everything, or there was a catastrophic failure on this board at one point in time. Strangely enough, they replaced all those transistors, but did not replace any of the capacitors. As you notice, all of them, the solder joints are original, and they haven't been replaced. So yeah, we had quite the failure on this board at some point in this thing's life. Isn't it neat how these things kind of tell a story as you go through them? So yeah, it looks like this Zener diode's been replaced, all these transistors in here, all these resistors, all kinds of stuff's been replaced. So I'm going to kind of go through all of this, and these are all ECG components here, so you can tell they've been replaced. Well, at least some of them are. This looks like an original transistor. So yeah, this one's been replaced with something. This is a metal can, which that's kind of not safe, because if this metal can touches this piece here, that might not be very good. Although this does look somewhat possibly isolated, but I don't know. So got our work cut out for us on this power supply, so we'll see if we can't get it cleaned up and get it replaced and working again. And all I could say about it is that it is working properly. And we also had a little friend here. Little, I don't know what that is. A bug? Yeah, that's a bug, like a millipede or something, or a carcass of it. Wow. Okay, so yeah, I guess this machine had a bug in it and I just debugged it. Great. All right, so let's get this fixed up and see what we can do with it. Okay, so we have everything done, and it ended up being a lot more of a chore than I anticipated. The protect circuit was real simple. The relay was bad, so thankfully the owner did send a new relay for this. I don't know if you can see it on this or not, but if you look at this contact, the one with the wiper on it, the tab, you can see how charred it is and just completely black, and all of the coating is completely off of it, tarnished off. Conversely, if you flip this side around, you can see that it still pretty much has that silver coating on it. And that's what happens to these, and really when they get that bad, if you clean them, it really won't last very long at all. So it is better to replace them. So thankfully he had a new one, we put it in, we got this recapped. This board is absolutely perfect. Everything was good. Now this one was a little more of a challenge. What we ran into was there was a lot of work. It looks like almost all of this board had been reworked because of damaged components. And the person who did the work did pretty good work. Although I'm a little bit perplexed that none of the capacitors were replaced. They were all the original. Even some of them still had the char marks on them from where the transistors were burned up originally. The owner sent replacement transistors with this, but the problem we ran into was that the replacements that he sent, when I put them in, they didn't bias up properly. They wouldn't work, and I had to go to an alternative ones that I had in stock. That's why it's very important not to just shotgun all of this and replace everything at once. You replace a component, you plug it in and make sure everything still works. If you go through and replace every single component, you just don't know, if it doesn't work, what problems you put into it. And so one by one I went through, and a couple of the transistors that he sent worked in the circuit, but most of them, all these little ones, did not. And these little ones here are ones that I had to pull out of stock to get to work. But fortunately it turned out good, and the power supply is very stable. It's working perfectly. Cleaned up the solder and put a nice new coat of conformal coating on it, so it's good as new. Cleaned all the pins, put a little bit of deoxit on a cotton swab and kind of cleaned them, put a little coating on there, and all set to go. So we'll get those in, and now we're going to start on the amplifier boards. Okay, so we're around to the replacing the output transistors, and the owner provided a complete new set of output transistors, really high quality, high power. They're actually much heavier duty than the originals that come with these, so they should last a very long time. And you can see the way that Pioneer built this heatsink. This is a very, very high quality heatsink. And you can see the machine surfaces that they have for where the transistor is actually going to make contact with the heatsink. And this isn't a mirror polished finish. So this is not something that I would probably use the silicone rubber insulators on, but rather this is the one I would use the traditional thermal paste and the mica insulators. So that's what we're going to do, and I know I did that little video on mounting the transistors, TO3s, and I know I got a whole bunch of questions is, can you actually go through the process and do one on a receiver next time you do one? So that's what we're going to do here, and I'm just going to show you how I go through and do this. So the first thing we're going to do is we're going to get some of this grease, and I already have it all over my fingers because it gets all over everything. It's a mess. keep paper towels handy. And we're just going to take a little dot of this, and like they say, a little dab will do you. Just a little bit like that. And I'm just going to take it and just apply it. I always start with the center part. The actual transistor itself is attached to this metal plate inside, and it's attached right about here where I'm touching now. So that's where I start, and then I work my way out. Now this top cylinder here, this is just a cap right here, and all this does is this covers the actual silicon transistor that's inside there, but the transistor itself is very tiny, and it's actually fused to this little metal flange here. So the flange is actually what's going to wick the heat off to your heatsink, and the purpose of the grease is to fill in all the little microscopic gaps in the metal, especially in the aluminum on the heatsink. If you notice, this is not mirror polished. It actually, if you rub it with your finger, it actually has kind of a little bit of a rough feeling to it. So you want that grease to actually go in there. So right there is what you have. You don't want to make it too thick, or the grease actually becomes like an insulator, but you don't want it too thin because you want it to be able to squish around in there and fill in all the little gaps. Now the next thing we do is we grab an insulator, and preferably a new one, and we place it on there like that. Now I can apply the second coat to this side, or I can apply it to the aluminum of the heatsink, whichever is easier to do. In this case, I'm going to apply it right to the heatsink itself. So take another little dab of paste, and we're just going to take it and apply it right like this. And this is going to take probably a little bit more than the transistor did, because again, having a rough finish, this is actually, as you brush it, it's going to kind of brush into all the little gaps, or all the little scratch marks that they put in there. And when we do this, it should couple up very nicely, and this really makes a big difference in how long these transistors are going to last. If you properly do this, you'll get the best thermal transfer of that heat from the transistor to the heatsink, and keeping the transistor cool is the name of the game. You don't want to overheat it, or it'll get damaged. Now I'm going to try to focus the camera down here. I don't know if this is, there we go. And you can see here's the little socket, and this socket actually just fits right down in here like this. So what I'm going to do is, it actually fits right into the notches in the back of the heatsink, and I'm going to hold this with one hand, and then I'm going to start the transistor from the other side with my other hand. And that's what's going to put this thing together. And you'll see on the transistor, if you actually look, one side of the transistor, the pins are actually closer to the holes than on the other side. So it is polarized, how it's designed here. So I'm going to do this off camera because I can't work around the camera, but you get the idea of what I'm going to do. Once I get it in there, we'll come back. And there you go, there it is. And then when you're done, you just take a little paper towel and just wipe off the excess heatsink grease. You don't want that on there, it's just messy and looks bad. You want it to look professional. And then when it's all done, you just want to snug these screws up. You know, they make fancy torque screwdrivers that you can set the torque on them and everything. I don't have that. Just understand that on the back of these threads are pretty small down here, and you just don't want to over tighten it. They do flex a little bit, and when you tighten them down, you can just kind of feel them start to really snug up. That's kind of where you want it. And if you snug them properly, they really don't come loose after that. They stay a pretty long time. They'll stay tight. And that's it. That's all there is to it. Now, if you have any other questions about this, go back through my videos. I did one on how this works and what kind of heat sink grease to use, what kind of insulators are available, and when to use the different types. And I just didn't get into as much detail on doing this as I did just now. So check that out if you get a chance. And there you go. Now you know how to do it. Okay, our first channel's all put together. I have the pots in. I ran the thing for a half an hour, biased it up. It came in absolutely perfect. And this channel is completely done and ready to go. So I moved over to the next channel and I just kind of checked the bias before I took anything apart. And unlike this channel, this other channel was reading way low on the bias. Everything worked, but I tried to adjust the bias pot and couldn't get it to come up very high. When I took the board out now to rebuild it, this is what I found. And you can see it's completely burned in there. It looks as if this did have a problem at some point in time, but I can't tell for sure. If you look right here, this resistor's burned, and there's all kinds of charring on the board under here. It looks as if these resistors may have been replaced. I don't know, but they look like factory originals. Well, they're not factory originals because the originals on the other side have rounded corners and so forth. So these have been replaced. This looks to me like at some point in time we had a short on the speaker terminals, because this is the snubber coil that goes out to your speakers, and these resistors are your current limiting resistors. So you can see the original for the other half of the transistor pairs. These are the original kind with the rounded corners. These are the replaced ones. So this was rebuilt. Now I don't know if when this failed, that's what caused the power to supply to blow, or vice versa. But again, there must still be some issue on this channel because the biasing is not correct, even though you saw that it performed very, very well. It sounded good. Everything was good. But I have a feeling we're still going to run into a few things in here. But whatever it is, we'll take care of it and make it like new. So looking at the bottom of the board here, whoever did the repair knew what they were doing. I mean, they did a very neat job of the soldering. Definitely looks a little neater than the power supply board was. But I'm still going to remove these resistors and clean that charred stuff off of there. Sometimes that charring can actually become conductive and can cause problems down the road. So we're just going to remove those couple components and clean them up. Okay, we have our 1K resistor out here. You can see it says 1K. I don't know if you could read that or not. And if we look at our meter, 2K. So it's double. So, and if you really look at it closely, you can see it's got some pretty bad scorch marks on it. So it's way out of tolerance. And that's the bizarre thing about this. These two boards that were repaired, whoever did it did a very neat job, but in the same token, the couple of inexpensive things they could have changed didn't get changed like that. So I'm going to go through every component on this board and make sure everything's in tolerance and everything's working properly before I put it back together. I removed the resistor, and there was a pretty bad charred area, but if you can see, it doesn't go up to the hole on this side, and it doesn't burn through. It's actually okay on this side, so I don't believe there's any kind of shorts or anything to worry about on this. And what I did was I just kind of sealed it off with some Corona dope. That'll seal up and get hard as a rock. and that'll keep that carbon there from softening up and chipping off down the road. That'll seal that off. So that'll be good. And then we're going to go through and test everything, make sure everything else is good. It looks like there are just a couple of little transistors may have been changed in here. There wasn't a whole lot of work done on this board, just around the resistors, and maybe a couple transistors were pulled out and tested. I'm thinking this one right here was replaced, and the rest of them all look original. Maybe a couple of the little drivers, and I'm still debating. They did use original parts, NEC parts, 2 SDs and 2 SBs, but it looks like the outputs have been replaced with original factory originals. So yeah, not bad, but we'll get it cleaned up. Okay, the more I get into this, the more I'm wondering how this channel ever worked. You saw how well it worked at the beginning of the video. So, right in here, along here, I removed it, is a 100 ohm resistor, and there's another one right here that I've desoldered. And it's 100 ohms. And there it is, connected up to my meter. And 34 mega ohms. So that resistor's open. And I believe the one in series with it is also open. That makes 3 burned up resistors so far on this board, and no wonder that the amplifier wouldn't bias up or wasn't adjustable. All the voltages are wrong. So, but then that begs the question, how did the thing work at all, you know? But obviously it did. Now, we only tested maximum power output. And usually when the bias is off on an amplifier, you really notice it the most with the crossover distortion at very, very low volume levels. And we didn't test that. So anyways, I'm going to keep going through all these components, and I'm going to very closely check everything on here. Because obviously, when this was originally repaired, whoever did it missed a lot of the faulty components. They got the transistors replaced and a couple of the resistors, but not all the little resistors were tested. So yeah, so let's continue on and see what else we find. Okay, let me get my microphone a little bit better here. What you're looking at right now is a oscilloscope waveform of the speaker outputs across the dummy load of the amplifier. Now we have the second channels all finished and rebuilt. It's good as new now. Everything's perfect, and all the output transistors have been replaced and everything. And I did everything to channel 2 except bias and DC offset. So one of those channels is actually the one that's perfectly aligned and everything's perfect on it. The other one is grossly, purposefully I actually drove the bias way down, almost off, and put a whole bunch of DC offset on it. Not enough to trip the protect circuit, but enough to make it DC offset. And we've always heard that, you know, if the bias and offset aren't set right, it'll really mess the sound up. But can you tell which channel is properly aligned and which one is not? Now remember, this is bouncing around simply because of the noise in the cables and in the room and everything. You got to understand, I am driving 1 millivolt RMS of signal into the amplifier in both channels. And we are only looking at about a little over 120 millivolts of audio. 120 millivolts, peak to peak. Take a look. This is 50 millivolts per division on both channels. So that's why they're shaky, okay? But that aside, can you tell which one is not properly biased and which one is? I can't. So it just goes to show that even though channel 2 had problems, the bias circuit didn't work at all because we had 3 burned up resistors, 2 of which were open, the other of which was out of tolerance but still at least had continuity. And of course the bias pots were bad, just kind of grungy. We were unable to bias that amplifier, but even with that, take a look. So I guess the point that I'm making is that even though you might have some issues with your bias, you may not see it just by looking at it without actually measuring. Now, so if that's the case, why does it even matter at all why we should bias this? Well, for 2 reasons. Number one, any DC offset on your speakers is bad. You do not want DC on your speakers. That will damage your speakers. And number 2, if the amplifier is not properly biased, not only could it potentially, now in this case it doesn't, but could it potentially cause crossover distortion whenever you go from the push to the pull, the NPN to the PNP transistor. You could get a little bit of a little bump right here, which we're not seeing. But in addition to that, if it is not biased properly, the transistors will become unstable. They could drift. They can overheat if it's over biased and cause damage to the circuit just from it sitting there. You're generating heat that you don't need. So the bias is extremely important, but it doesn't necessarily mean you'll see it or you'll hear it. At least not on every amplifier, and this is a really good example of that. So I just thought that was interesting, and I thought I'd share that with you guys. I thought that was pretty interesting. I thought for sure I'd see crossover distortion if I had this one way out to lunch, but being that this thing worked so well right out of the box, it got me to wondering, well, what if? So I said, hey, let's do an experiment here. So there you go. Living proof that just because your bias and offset isn't perfectly set doesn't mean that the amp still won't perform properly. There it is. Oh, and just in case you wanted to see, I don't know if we can get focused on it, but 1 millivolt RMS. That's all we're putting out to each channel into the amplifier. So the amplifier is almost not making a signal at all. Very low volume. And there's your results. Okay, so we're starting to work on the tone control section and have this all removed. And pretty much the way this comes apart is like all the other SX series ones. I've done 100 of them. You could go back through my videos. And I've already replaced these capacitors here. And these are the light orange capacitors. And I try to use audio grade on these boards. But a lot of people say don't replace these bright orange ones. These are the ones that are special audio grade capacitors. They're in the audio path, and they say that they're such high quality they never go bad. But time and again, I have an example here on my meter. I have a 2.2 microfarad capacitor, and you can see the way they're made down here. If I zoom in, you can see they are very high quality. They're actually, you can see they're all sealed on the bottom. They don't leak. But when you see up here what's going on, it tells a different story. And I got the polarizing lens on here, so sorry about that. But if you take a look, it's 2.7 or 2.8 microfarads, so it's a little bit high, not bad. But look at the ESR on this, 7.05 ohms of ESR at 1 kilohertz. And remember, these things have to be able to work between 20 hertz and 20 kilohertz. If I go to 10 kilohertz, the capacitance stays on pretty good, but we still have pretty nasty ESR. And of course this is going to be ridiculous, and that's normal. And down to 100 hertz. You can see at low frequencies, your ESR is clear up to 28 ohms. Now, let's compare it to a 2.2 microfarad capacitor, a new one. And here's a 2.2, one of the film capacitors we replace it with. And I'll just remove the probes here and just connect them right up. And what happens to our ESR? 0.7 ohms, and it's right on 2.3. And we can go right up through the different test frequencies. Right at 2.2 microfarads, 0.9. 2.2 microfarads, now it's dropping to 0.2. And even at 10 kilohertz, 2.2 microfarad, still 0.3 ohms. So the point that I'm trying to make is that as these bright orange capacitors age, this gets worse and worse. These will get up into the 10, 20, 30 ohm range. I've seen them. And it's just, even though they look pristine on the outside, these special capacitors do have a life expectancy, and they really do need replaced if you want the receiver to work at its best. Remember, these are in the audio path, so they don't have 100 or 120 hertz that a normal power supply capacitor would see. They have frequencies up in the range of 20 kilohertz, and they have frequencies all the way down, below 20 hertz, depending, with subsonics and everything. And those frequencies definitely will affect the capacitor if it has a high ESR value. So I just kind of wanted to show you all that and give you an example of why I replace those orange capacitors on these, at least on these Pioneer gear from the 70s, and a lot of the other gear that's out there from that same era that has these same kinds of capacitors. All right, we're all put back together here. Got all the caps done. These ones do have some tantalums, but on the tone control boards, the tantalums really don't have much voltage on them. And I've found that these ones, at least in this board, never, ever, never fail. They're very reliable, and tantalums have extremely low ESR, very low noise, very good capacitors, so I tend to leave them alone. I will not replace those. But everything else is set to go. Controls are all cleaned and deoxed, and actually somebody had already been in here and hosed these down, and got a lot of grease on my hands to prove it, but I went through and cleaned it and sprayed them out. Got everything working good. So putting this together, and we're going to move on to the switches and then go up to the last board, and we're moving right along. Okay, I just finished out swapping out the soft start relay, and you can see you can get the old ones or get the new ones here, and there's the part number. And all you really have to do, because this has that funny little flange on it, is just slide the cover off of the old one, slide the cover off of the new one, and swap them around, and everything will work perfect. And then that way you don't have to modify any of the mounting or anything like that. It just pops right on. It's the exact same replacement. So there you go. Alright, I now have both of the amplifiers biased and set properly, and they're working really well. And I've removed this cover right here next to the tuner board. And what you're looking at right now is called the Equalizer amplifier board, which the rest of us kind of know better as the phono stage. So this is what's going to take the signal from your phono cartridge on your record player, on your turntable, and it's going to act as a preamplifier, And as well, it's also going to apply the RIAA curve that for LPs. And that's achieved by these really highly precision resistors, which these are not capacitors, these little maroon colored flat packs. These are 1% precision resistors, and these are two polystyrene capacitors that are 1% precision. And by putting this little network in there, that's what sets the equalization for the magnetic phono. Now the other thing you might notice is I've shown this on a couple other videos. You'll see that 4 of the transistors on here have little orange dots on them. Once again, whenever you see these little paint dots like this on this vintage equipment, that usually means that these are matched transistors. And again, I cannot find the document anywhere. I have searched the internet, but I'm pretty sure that Motorola or Fairchild or one of those companies at one point in the time had a color coding system where each color represented a gain match. So you saw on some of the other units they had blue dots. These ones have orange dots on them. But the whole idea was they beta checked the transistors when they produced them, and then based on what their forward current gain and so forth was, they would put them in a certain bin, a certain class, and then they would put that dot that represented that class. And in that way, rather than going through the tedious task of trying to match your transistors when they built these, they would just go ahead and if you picked 2 of them with the same color dots, you knew they were in the same range and they were pretty close matches. So it's kind of a production way of matching transistors ahead of time. So that's at least what I've always been taught. So anytime you see these with these dots and you need to replace one, you have to remember that you need to replace them as a pair and they need to be matched. That's pretty much what that means. Now, this is your differential pair at the front end of the preamp, and that's what's the output of that little signal is going to feed through this network, this equalization network, and then the rest of this circuit will send the signal on out to your actual flat amp and tone amp and preamp section. So all we're going to do on this is we are going to replace these 1, 2, 3, 4, 5, 6, 7, 8 electrolytic capacitors. These orange ones, once again, are high-end audio-grade electrolytics, so they will get replaced either with film capacitors or with audio-grade electrolytics, depending on what they are. And then the rest of these are pretty much standard electrolytics. They'll get replaced. And the rest of it we're going to leave alone. Unless we have excessive noise from any of these transistors, and that can happen. Sometimes a transistor can get noisy, but I typically will not replace these because these are all kind of put together and tested, and if it works, you're better off leaving well enough alone. If it does not work, then you have to go through the task of matching and doing things like that. But the only way to test these really is with time. You have to connect it up after you're done, set it to phono. Usually you don't even need to connect a signal to it or play a record through it. Really all you need to do is listen to it, have the volume up at a reasonable level in a quiet situation, and just see if you hear any hisses or pops or clicks over some time as these warm up. And that's really the only way to really test these phono stages, at least that I've found. Because it's when you have transistors that are noisy, they're going to show up in this section. A lot of the other parts of the amp, the gain isn't, it's not so sensitive to low signal levels. So unless there's a real bad problem, it's pretty obvious. And, but these ones, the least little bit of noise can really be amplified. So basically I'll do this. I'll turn it on while I'm cleaning up around the bench and everything and just listen to it. Give it a good time to run, and if we don't hear any hiss, we don't hear any pops or cracks, we know that we're good. And then, you know, of course, we'll do a little test on it afterwards. So that's what we're doing, and that's just a little rundown on the phono stage of these. They're actually pretty good phono stage in these. They work pretty well. So let's get it recapped and get it back together. Okay, the deed is done, and we're gonna get this put back together and then just do a quick test of it, make sure everything's good, everything's working, and move on to our next part. Where really the only thing left now is going to be the tuner after this. Okay, I have the receiver all put together and powered up, and I'm just going to show you how sensitive this circuit is. If I turn the volume about halfway up, you can pretty much hear, if you can hear that. I don't know if you heard that or not. And if I just move my hand over here, watch. Anywhere in there. I'm not touching anything. That's how sensitive it is. So you can hear the sound. Off. On. Now watch when we place this cover over here, and we'll show you the importance of shielding on these stages. And I'll just hold it down with my hand, and there it is, cranked almost all the way up. Little tiny bit of hiss, but as you can tell, much quieter. So yeah, shielding on these is very, very important. A lot of the phono stages and some of the lower end receivers don't have that kind of shielding, and that's why you hear a lot of hum and hiss and things coming from them. So we're going to just listen to this for a while and make sure the transistors are happy and there's no noise or any kind of thing like that, and then we're going to move on to our tuner alignment and checking that all out. Alright, taking one last look at it before we put it all back together, and I must say this tuner was probably one of the most closely aligned tuners that I've ever brought in here. Tiny little touch up of the discriminator and a wee little touch of the oscillator, and other than that it was absolutely spot on. And this thing is so sensitive. I mean, down in the basement at the bottom of the hill living here, I'm picking up stations with before, you know, even with not even hooking up the antenna. So it's a really hot tuner in this thing. Every bit as good as the SA or the TX9100, and maybe someday we'll get to see how it keeps up with the old F28 and F26 maybe. We'll see how those work, if we can ever get a working one. So yeah, this turned out great. This thing sounds amazing, and I'm going to put it together, and maybe we'll do a little bit of testing on it and see what it sounds like. Okay, got the old signal generator set up, and even though this cheap oscilloscope has a lot of lag for the refresh on the screen, you are looking at 10 hertz at 162 watts per channel. And other than my trace kind of being jig-jaggy the way this scope is, you got a pretty clean signal there. 162 watts per channel at 10 hertz. So let's now move it up to 20 kilohertz and see what we can get. Okay, and now I got 20 kilohertz on there, and again 160, little over 100, about 165 watts per channel. And you can see the very bottom of this one is just starting to break up a little bit. This one's a little bit better, not much, but they're both tracking very, very closely to one another. If you look at channel 1 and channel 2, they're all, it's looking good. Everything looks great. So, yeah, so far so good. Heat sinks are getting moderately warm with full rated power running continuously. They both feel right about exactly the same temperature. So yeah, I think everything's looking good here. So let's see if we can give it a little sound test and get some music on here and see what it does. Of course, short of taking this beast over to the main rig and setting it up with the Klipsch reference speakers, those are about the only ones I have that would fare well with full output power of this thing. This thing is a beast. It is really powerful. And the not only that, but just the transients that this thing can do with those huge capacitors. You know, if a big bass note comes through, it'll just push it straight out to your speakers. No clipping, no nothing. So, you know, in its day, the SX-1250 was the very best receiver that Pioneer had to offer. And really, the 1280 had a little higher power and a little lower distortion. Definitely didn't weigh as much. They kind of cheapened up on some of the mechanical parts, but it was a good receiver. But really, they didn't outdo this until they came out with the SX-1980, and that's in a whole class all by itself. And maybe one day we'll put one of those on the bench and take a look at that. But I can't see any reason anybody would want or need more than this thing can put out. It is phenomenal. And as you saw earlier with the earlier test, even putting out 100 millivolts RMS to the speakers, there was absolutely no crossover distortion, nothing. So this is a very, very clean amp. I'm really anxious to hear the phono stage on this, and I'm kind of halfway thinking maybe I want to set up a turntable and listen to it at least a little bit. But this is it. Here it is. And everything's turned out pretty good. Alright, we're going handheld on the camera. And I've just basically set this on top of my SX-1050, and you can kind of see the size difference in them. They're not that far apart, but it is a little bit bigger. But other than that, look at the knobs and the controls, and you can see the similarities between these two receivers. They're almost identical, other than the power supply and the rated output power. But other than that, they're very, very similar receivers. So I just have been playing this for a couple of days, just making sure everything's good on it. And just thought I'd have a little fun before packing this thing up and sending it back to the owner, who will probably be very happy to get it back. So, you know, the YouTube library, you can always find some crazy stuff on here. So I found a song on our little player up here called Toe Jam. I can't make this stuff up. So let's listen to some Toe Jam and see what it sounds like. I know what it smells like, I just don't know what it sounds like. So let's check it out. I don't know, do your feet hurt yet? Actually, this thing sounds pretty good, I think. I don't know if I'm swamping out the microphone on the camera. I know one thing, it'll move these speakers big time. This is a very clean sounding, powerful receiver, so I gotta say this one's ready for the road. So as always, thank you all for coming along to watch me do this. And as always, I wish you all peace, joy, happiness, and good health in your lives. And no toe jam. And until next time, be well and take care. And we'll see you soon with some more videos. Take care. Bye-bye.